Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. That is problem 70, climbing stairs. So this is actually a very routine problem which is marked easy by Leetcode. So in this video, we're going to practice the standard dynamic programming. First, let's look at the problem statement, and then we do the analysis, and finally we share two formats of solutions. First, the problem statement. We are climbing a staircase. It takes n steps to reach the top. So each time we can either climb 1 or 2 steps. In how many distinct ways can we climb to the top? So this is the problem main statement. So let's look at the examples. So in example 1, so n equals 2, there are 2 ways. So either you can jump one step each time, so this is the one way, or you can just a single 2 steps, so this is another way, so we have 2. So you can actually also check for n equals 3, there are 3 ways, right? So here the constraint is the following. So n is bounded below by 1 and bounded above by 45. So this 45 actually is not a very large number. So with that said, we are ready to do the analysis. So first, let's mention again. So we are going to use dynamic programming. So this is typically a starting problem for practicing dynamic programming because this is a daily challenge problem. So we are here making a video for it. So here I'm going to use dp. So I'm going to define dpi and interpret it as the number of ways to climb to level I. Then the dp update rule is very simple, right? So if level equals 1, so there's only one way, just jump one step. If level is 2, so it just there are 2 ways. You can just jump a single 2 steps, or you can jump one step twice. So in general, so if we consider level I, actually there are 2 possibilities, right? So we either from the I-1 level, then jump 1 step, or we jump a 2 step from level I-2. So these are the positions we can use for the previous information. So this generic recursion relation is for I greater than or equal to 2. So actually here, if you interpret I as null and the I-1 and I-2 as the previous 2 steps, so this is nothing but Fibonacci numbers with if we initializing using the correct convention. So this is also a connection of this problem with the Fibonacci numbers. So with that said, actually this problem for coding is sort of straightforward or over both. So let's first share one solution, which I'm going to use ON space. And then we are going to write another solution which uses O1 space. So first, if n equals 1 or n equals 2, so we are going to return n, right? So notice that n is greater than or equal to 1. So this is the base cases. So now let's look at the case for general. So I'm going to initialize a list which has length n plus 1. So in other words, we are going to use this interpretation. So number of ways to climb to level I for dpi. What we are going to return after we set down the dp table is dpn or dp-1. So we just need to iterate for I in range, say 3 up to n plus 1. So, but here we haven't finished the initialization yet. So for dp1 we're going to have 1, and for dp2 we're going to have 2. So this is actually pre-assumed. So or you can look at here. So now let's look at the iteration. So it's basically to copy the dp update rule, dp I-1 plus dp I-2. So notice that I is greater than or equal to 3, so I-2 is greater than or equal to 1. So which we have already set. So therefore, this always work. So with that said, we are going to return in dpm, right? Or you can write dp-1. So that's one solution format. So we can do a test. Yeah, it passes the first example. Now let's look at another extreme. So when n equals 45, yeah, this is actually a very large number already. So now let's look at the generic case. Yeah, it passes all the generic cases. So this is the one solution format, so which is actually beginner friendly. So now let's copy this function signature and let's see, oh sorry, so def, let's see if this still works. Yeah, so let's copy this part. Let's call this one version v1, and then we're going to use o1 space. So actually the main step iteration is here, right? We do not need to use this array for storing the state. So we are only care about the last state. So for this purpose, let me first do a check when n equals 1 or n equals 2. So we're going to return n. So this is, we can regard it as a starting point. And then we're going to set two parameters, a, b. So 1 and 2. So it's corresponding to the first two steps. And then we're going to iterate for this many times. In other words, n plus 1 minus 3, that is n minus 2 times. So for I, so actually we can use this for a dummy index in range 3, n plus 1. So you can write, so here this this number of iterations is important. So not you can start from 0 but write n minus 2. That's still okay, because in this case n is greater than 2, right? So we're going to do this. So we are going to set a equals b, like moving forward one step, and then a plus b. Then finally we just need to return the state of b. So this is another solution. This b actually corresponds to this dpm. So with that said, let's look at the test. Right, so it passes the 45 case. Now let's look at the generic case. Yeah, it passes all the cases. So as we mentioned, so here we can write directly n minus 2, right? So the number of iterations is essential, right? Right. So let's see. Yeah, it passes all the cases. So let me write some notes. So n minus 2 means iterating for n minus 2 times, right? So if you like, you can write range 3 n plus 1 like in here, but this is a tiny detail. With that said, I guess that's about it for this specific problem. You can have a look at its extensions and connections with other problems. With that said, I guess that's about it for this video. Thank you.